Now we're going to deal a little bit with abstractions. When we say abstractions, these are the type of problems where they give you variables or they give you something not concrete. In most cases, you're going to want to substitute numbers in order to make these things make sense. Let's look at an example. Let's say they give you a problem that says a drill bit is used by an oil company that will last for N feet. If each hole is Q feet deep, how many drill bits are needed for X holes? Alright, there are no numbers here. And I don't know about you, but I don't like flipping around N and Q and X. It's hard for me to keep track of it. So let's give these things value. Let's say that N, the number of feet a drill bit will last, is 100 feet. And let's say that each of these wells is Q, or 300 feet deep. And we want to do 4 wells. Well, you just divide 300 feet by 100 feet to find out how many bits you're going to need, wouldn't you? And so you need 3 bits per hole. If I'm going to do 4 wells, that's 3 times 4. So now let's just substitute the letters back in for the numbers. Q goes where the 300 feet is. N goes where the 100 feet is. And you multiply that by X. So that's going to give us QX over N. Put numbers in there so you can make these things make sense. Now this strange looking thing is what we'll call a letter problem. In this case, they want to know the value of R. It looks unsolvable, but you have to realize there's a key to these, and the key lies to the left. We're used to adding from right to left, so you're going to start working and doing your work over there trying to solve for B. The key here is S. We want to know what S is, and S has to be a 1. Think about it. The 2 largest 3-digit numbers are 999 and 999. You add those together and you get 1,998. There's only one digit that S can represent, and it has to be a 1. Well, if it's a 1 in the thousands column, it's also a 1 in the tens column. That's the key to solving this problem. T represents a digit. Well, there are no 2 digits I can add together to give me a 1. So how did that 1 get there? It had to be carried from the ones column. So you have to carry that 1, and it has to come straight down, which means that T has to add up to something that ends in 0. So T has to be either 5 or 0. But since we have to add T to S to get a number greater than 10, that tells us T has to be 5. And now we can solve it. Because if T is 5, that means B has to be a 2. And if B is a 2 in the hundreds column, it's got to be a 2 in the ones column. What can I add to 4 to get something that gives me 12? 8. R has to be 8. When you start at the left side and work your way back logically, you can solve these problems.